All right, so today's lesson on logarithms is going to first start into how to evaluate. Now, we have two different kinds of logs. We have log logs, which have a little base subscript that tells you what base it's in. And what base means is how many, it's like when you think about an exponent problem. Your base is the number that you're multiplying together. So when I say like 2 to the third power, I mean 2 times 2 times 2. It's the base is the number you're multiplying together. The exponent tells you how many times to do that. Well, in a logarithm, this base tells me I'm multiplying a bunch of tens together to get the product of 100. So if you just think about that a minute, that one you might could actually think it through and understand the math. Because how many tens do you have to multiply together to get 100? 2, because 10 squared is 100. So the answer to a logarithm problem is the exponent that goes with this base to make that product. Okay? Let's think that through again. This is our base, and this is our product. And what your calculator can do is help you define what this is equal to, which is an exponent. So with that one, I mean, you know, we could think that out in our head, and we know what the answer is already because we understand that 2 tens, 10 times 10 makes 100. But how do I type that in the calculator? Well, with a calculator, all of these can be typed in. Does anybody in here have an 83? Does everybody have an 84? You do. Okay, yours will be a little different. But, come on. First of all, there's an LOG button here for you because that's the only LOG button you have. Okay? So I'm going to show them first, and then I'll show yours. For the rest of you who have the 84, it's hidden under the Math menu, and if you go up twice, you'll see it says Log Base. And Log Base allows you, when you put in to hit Enter, well, I got some weird stuff on the end of mine, but anyway, let me get rid of that square root symbol that was left on the screen that I didn't realize was there. All right, Math. Come on. Do you see how it gives you what that looks like? So all you got to do is type it in there and hit the arrow over and type it in the other part. For you, it's a little different. It's not hard, but it's different. You're going to use this log, okay? And what you're going to type is, come on, right? Log of the product divided by log of the base. So for this question, you would type log of 100 divided by log of 10. And the 83 will do it. But 84's, all you've got to do is type it the way it looks. Now, if you want to do it the 83 way, everybody could do it the 83 way. Because everybody has the log button that's over there above the store key. But the 84's let you type it just like that. And because they let you type it just like that, that means that you can have a little bit of an extra edge because you don't have to remember how to type it. You just got to remember where it is in the calculator. But this isn't hard to type. Are you okay with that, Skylar? You got it? Okay. So why don't y'all type all three of those in and see how it works for you, making sure it works to give you an answer. Not all of them are whole numbers, so if you don't get a whole number answer, round it off to 3 places. That's another thing you have to remember because every power problem doesn't work out to be a whole number. And one of the reasons you may say, well, Ms. Johnson, why did they choose 3 places? We've always rounded everything to 2. I mean, think about it. Square roots, we round it to 2, right? Everything deals with pi, we round it to 2. Well, exponentials are a little more accurate than those factors. So we do exponentials and logarithms to 3 places because of the accuracy that we can get. Is that better? Can you see it better? So even though LOG can be typed 2 different ways, It still gives the same answer no matter what it does. Is everybody getting good answers? Have they been all whole numbers? I bet number 2 is a whole number. Is number 2 3? Yeah, because we know it's 2 times 2 times 2 makes 8. But I bet there's nothing to the third power that makes 42 come out to be a whole number, is it? And that's where, if you knew your perfect squares and your perfect cubes and your perfect fourth powers, you'd know the answer immediately. In fact, you really should start trying to learn some of those that you don't know, because you should know your perfect cubes up to about 6 and your perfect fourth powers to up about 5, because that would take care of the majority of the ones you'd ever see that are whole numbers. So when you do log of base 3 of 42, what decimal do you get? 3.402. Okay. And what happened when you typed in log base 5 of this negative fraction? You don't get an answer. Did anybody get one? Because if your mode's not turned on correctly, you could get one. Your mode's supposed to be on real right now, and if you have imaginary turned on, it'll give you an imaginary number. If you have an error message that said non-real, does that mean it's imaginary? Well, kind of. It kind of means that, but really what it means is it's undefined. So the correct answer to number 4 is undefined. When your calculator gives you an error message like non-real answer, that's usually because it can't do the math, no more than it can say the divide by 0 answer. Because what's 42 divided by 0? Undefined. 0 divided by 42 is 0. But 42 divided by 0 is undefined. We've never been able to divide by 0. And so there are certain things in math that are just undefined. All right, does anybody have any problem with typing LOG problems in their calculator? Easy enough? All right. The second thing we're going to look at is how to do natural logs. Natural logs are the button LN. And we will be using the one that's on the front screen of your calculator. It's above the key, that's above the store key, right below the other LOG button. Now, of these problems, let me just say a couple of things and I'm going to let you type them in. 1, when you hit the LN button, it brings a parentheses up. So like if I was typing this in, it would put a parentheses right here. Where do I end it? Do I put it after the 5 or after the 2? Well, that's what it seems like I should do, right? But actually, unless they're already in the problem, they're only putting one number inside of there. So that's really important to know, because they don't want the addition in there. If they wanted the addition in there, they'd had to put the parentheses in there for you, because that would tell you to do the addition first. So they only want the 5 in there. So if there's stuff after it with adding or subtracting, it stops before the adding or subtracting, unless they automatically put it in there. Now, I wrote this one in here because I wanted you to be keyed into that's a -2 and not a subtract 2. But I could have left it off, and it still would be -2. All right, so type these 4 in, see what you can get, and I'm going to pause the video while you do that to see if you're having any trouble with typing them in. All right, so as we go through these problems, we are going to figure out where these 3 numbers go in these formulas. So this is my base, this is my exponent, this is my product. So if I'm going to make a log, the log base product equals exponent says drop the base down and make it a subscript. Isn't that what you call it in computer class, a subscript if it's below the line? And then you put the product down on the same line with the log, put your equal mark, and put the exponent on the other side. That's all you do, is drop your base down lower and switch the exponent and the product's positions. It's that simple to make a log. And if you weren't sure if it was right, you could type that log in the calculator and make sure it has the answer -2, so there is a way to check that. Because it won't come out -2 on the calculator if you put these numbers in the wrong place. So over here, what's my base? What comes after the base in a log? That's right, the product of 216, so that makes my exponent go on the other side 3. How hard is that? Not hard, is it? You just got to remember the format. If you remember the format, it's very simple. All right, now let's look at the next two. So let's go the opposite way. Let's write the exponential form for each log. Now, first of all, some students, sometimes they say, well, how do I know I'm doing an log log instead of an ln log up here? Well, do you see any e's up there? You don't do ln unless you're doing e. Same thing here. I see log. That means I know there's a subscript coming up that's going to start my problem. I know that this is my base, this is my product, and this is my exponent. So if I know the format, then it doesn't take very much to write my base bigger, put my exponent back on it, and put my product back on the other side. And if I've done it right, I could type 2 to the 6th power in the calculator, and it will tell me 64. So that could be my check. Because if you type it any other way, it won't come out 64. So it's real simple. You put your base down, you switch the two. So my base in this problem is what? And what will I switch makes my problem up here have a -2. Now let's see if that makes sense. If it's 4 to the -2 power, won't it go down and become to the +2 power? And what's 4 squared? 16. And it's on the bottom because I moved it down. So it makes sense. You can't put them in the wrong place. It won't give you the right answer if you do. So it's that simple. You just write your base bigger, and switch the exponent product, and then put it back where it goes. And again, I know what I'm working with because I can see the base in either format. Whether it's a logarithm or it's an exponential, I can see the base. Everybody with me?
You leave that up for a second.
Yeah. I'll just freeze it so I can fix my next screen while you're doing that. I only got 4 more questions to show you. Because if I can do it with log, I must be able to do it with e and ln too. The natural ones. These are not natural. I know they're not natural because it used the word log and it has a number for a base. Natural logs and natural exponentials are base e. Are you ready? All right, so let's look at the format of an exponential that's based on natural ones, and let's look at the format of the log. So it's e to an exponent equals product. Now e is a natural number, so it has to be made into a natural log. But if I tried to make this into log, look what it would be. Log base e of product and exponent are switched, aren't they? Well, mathematicians thought, well, it kind of looks weird having a letter down there. So they decided to take all of this out and put in the letters ln for natural log. And so therefore we do ln of product equals exponent, we just throw the e away. So e to an exponent equals product becomes ln of product equals exponent. You don't see base e in the final answer. So this is all about natural log and natural base e. Still running. All right. So let's start by looking at write a natural log for each, well, I left the word 4 out, for each base e. These are already base e. I know they're base e because the base of the exponential is a letter. That's why they have these approximate symbols in them, because they're not exact answers. They've been rounded off. So as we go through and make them into logs, now we could take the time to make the log log. I don't suggest it, but you could. You could say, Well, if I can get my markers to right. I could say LOG, drop that base down and switch them. Whoop. I could do that. But that's kind of a waste of time. Because the answer to this question is LN. And you switch them and you throw the E away. Because they came up with a special thing to write for logs of base E. So it's even quicker to write down because you don't have to write a subscript. So over here in number 6, it'll be ln of 20.086 is approximately 3. Because you don't use the E, the ln is the inverse of E because they're on the same button on the calculator. Does that make sense to y'all? Now again, we could write this first if we need to, but it's got to be this when it's written on the final answer, so we might as well just go to that. All right, the last part of this lesson is going the other direction. What if you already have a natural log with ln, but you want to change it to an exponential form? Now, for some students, until they get more familiar with it, they might decide that they want to kind of show a little more work. And you might decide you want to at least put that in your notes. But after you get real familiar with what it means, you may not want to do this every time. But the first thing you might want to think is this is base E. If you take your ln and change it back to log base E, then it becomes what we studied earlier. If I want to change it back to an exponential, I just switch two things and put E as my base. So E is the base. These two are going to switch places because this is the product and this is the exponent. So I'm going to put my exponent back up and put my approximate symbol in here with my decimal product. Because exponent and product switch no matter which one of these things you're making. They always switch. But there's nothing up here in the original problem that tells me it's base E except for the fact that I know that ln and E are on the same button on the calculator. Now, whether you do this part about changing it to log base E or not, you've got to understand ln becomes E and E becomes ln. They're vice versa because they're on the same button on the calculator. So over here, I'm going to have E to the 6th power is approximately 403.429 because ln is the inverse of E, and I switch them. What do you think? All right, we've only gone over half of 4.2. In Canvas, under 4.2 are two different worksheets. You know how now to do part 1. Okay? So you can finish the assignment on 4.1 if you haven't already, and you can do the 4.2 part 1 worksheet for 4.2 on what I've just gone over in these notes. And if you've got the 4.1 done, you can turn it in, or if you don't have it done, you can take it home and finish it if you need to. Yeah, it will be for a grade, but we may put it with the part 2 before we turn it in, okay, which we'll learn tomorrow, okay?